My dear student, it is now maybe uh, not easy time, or you can say a little difficult time. Because of this coronavirus, our study stops, but university is doing best to provide education to our student, and this is first time mostly our instructor and as a teacher we all are working online, and maybe for student this is also first opportunity to study online. uh, every system has some benefit. Definitely it is not 100% perfect everything, because when you are in normal class and when you are studying online, there will be definitely a little difference, because in when you are physically there in class and you can interact with the teacher directly, that is completely different when you are studying online. But the benefit of online is you have a recorded video, and you can listen to your instructor as many times as you like. You can repeat the lecture as many times as you like, and so that is the I think biggest advantage for this online study. Now, I will start my lecture. So today we will discuss about vector function. If you remember previous lectures, we already studied vectors, but we study vectors that was not function, that was only vectors that was dealing with dot product or cross product, and there was no function actually. There was a position vector, but your position vector was only, it was dealing with the, instead of here you can see RT, here f of t, instead of f of t there was only number written just like any real number, and then in g of t there was some real number, and then h of t there was some real number. But now we are defining the position vector. Say I can define the position vector RT equal to f of t I plus g of t j plus h of t k. Here your f of t, g of t, h of t, they are function, and they are function of time. So the biggest difference between the previous lectures that we already studied about the vectors, so there was only here instead of f of t, g of t, h of t, there was a real number, but now here we will be dealing with the function. So you can see f of t, g of t, h of t. So that is the main difference. And then the other difference is because f of t, g of t, h of t, these will be functions. So in real life, mostly we are dealing with real life problem, and real life problem needs some function. So that is why this topic is very important. So, so first we can define velocity. So velocity is the derivative of the position vector. So our position vector is given this, rt is equal to f of ti plus g of tj plus h of tk. So if you take first derivative of the position vector, so it means rt is our position vector. If you take first derivative of r, so which is dr over dt, so that will become our velocity. So what we are going to do, so we will take derivative of the position vector individually. It means we will take derivative of f of t individually, we will take derivative of g of t individually, and we will take derivative of h of t individually. So it means your velocity will become f prime ti plus g prime tj plus h prime tk. So it means whenever we are going to find velocity, you need derivative. So for this topic, you must know all basic derivative formulas. So then this lecture will be very easy for you. And then if you want to find the speed, so what is speed? So speed is nothing but speed is the magnitude of velocity. So you already find the velocity, and now you will take magnitude of this velocity vector. And so if you take the magnitude, you know the magnitude of the simple vector was in previous lecture v1 square plus v2 square plus v3 square and then square root. The same formula we apply here. Here our velocity vector is given as this. So f prime ti plus g prime tj plus h prime tk. So now the speed will be magnitude of this velocity vector. So that will be f prime t whole square plus g prime t whole square plus h prime t whole square and then whole square root. So that will be your speed. And then acceleration. So acceleration is the derivative of velocity vector. So if you have the velocity, so if you take one time more derivative of the velocity, so that will be your acceleration. So we'll denote acceleration with a. So this will be dv by dt. Or if we are dealing with the position vector, so your position vector was rt this. Now if we take first derivative of position vector, so that was our velocity. So if you take a second derivative of the position vector, so then this will become acceleration. You can see we can write acceleration as dv by dt, or we can write this as d square r by dt square. It means two time derivative of the position vector. So we can say, because our velocity vector was f prime t, so if you take one more derivative of the velocity, so this will be f double prime t. Then similarly this g prime, if you take one more time derivative, so this will be g double prime t. And if you take one more time derivative of h prime t, so this will be h double prime t. So so from this you can see if our position vector is given, so you can take velocity, so take first derivative of the position vector, and if you take second derivative of the position vector, so this will become acceleration. Or you can say if you take first derivative of the velocity vector, so this will become acceleration. And speed you will find just magnitude of the velocity vector. If you take the magnitude of the velocity vector, so that will become speed. So if you remember these three formulas, so then we can easily solve the question. Now we will move to the example. Now our first example is, if you see the example, our first example is, let rt is equal to sine ti plus cosine tj plus tk be the position in space at time t. Now the question is, find velocity, speed and acceleration of the particle. Now for solution, since our position vector rt is given as sine ti plus cosine tj plus tk, and we know what was the velocity. Velocity was first derivative of the position vector. So it means we will take derivative of r of t. So if you will take derivative of r of t, so that will become velocity. So what you will do, you will take first derivative of sine t, which is cosine t. Derivative of cosine t is minus sine t, and then the derivative of t is 1. So we take individual derivative of all these functions. So if I simplify this, so this will be cosine ti minus sine tj plus k, because 1 multiply k, so this will be only k. Now if you want to find speed, so speed will be magnitude of the velocity vector. So if you take magnitude of velocity vector, so the formula was, we have to take the square of cosine t, so which will be cosine t square plus square of the second component, which is minus sine t, so minus sine t square plus the square of the third component, which is 1, so 1 square. Because if you remember the formula, it was f of t whole square plus g of t whole square plus h of t whole square and then whole square root. So same you can see. So first we find the velocity and then we find the speed. How we are finding speed? We take square of this plus square of this and plus square of this. And now if you take the square of cosine t, so this will be cosine square t, square of minus sine t whole square, so this will be sine square t, because you know it is minus and there is power 2, so this will become plus, so this will be sine square t, and the square of 1 will be 1. And you know the formula for cosine square t plus sine square t from the trigonometry. So cosine square t plus sine square t, so it is 1, so 1 plus 1 is 2, so this will be 2 square root. So that is our speed. Now for acceleration, it is we denote with at, acceleration. So what was acceleration? Acceleration is first derivative of the velocity vector, the second derivative of the position vector. So now here we find the velocity vector, vectority. So it means this cosine ti, this was your velocity. So if you take derivative of cosine t, so this will be minus sine t. If you take derivative of sine t, it will be cosine t. And here is 1, you can see this. So the derivative of 1 is 0. So if I simplify this, so the acceleration will be minus sine ti minus cosine tj and plus 0k. So no need to write 0k. So this will be your acceleration. Now here, this is very interesting. Note that the curve RT, this curve RT, which was sine t plus cosine t plus tk, this was our question. That is a very special curve, and that curve is called spiral curve or helix. You know, spiral binding. If you have seen notebook or if you go in the photocopy shop, you can ask photocopy person that I need spiral binding. So it means this curve actually represent a spiral. So its shape is like this. So you can see this spiral. So it means this curve is very important, and we can use this curve in real life, in many real life problem, wherever this spiral shape will come. So that represent this curve rt is equal to sine ti plus sine tj plus tk. It means whenever there is a position vector, that position vector will represent something very special that will be needed in real life problem. Okay, so I hope this example is clear. So I will repeat it one more time. So what you will do, so if your position vector is given, so to find velocity, what you need first derivative of all the components. So the derivative of sine t was cosine t, derivative of cosine t was minus sine t, derivative of t was 1. We simplified, we get the velocity vector. To find the speed, what we did, we take the square of first component, square of the second component, square of the third component, and then we take the square root. We simplified, we get the speed. And to find the acceleration, what we did, we find the first derivative of the velocity vector. So the derivative of cosine t was minus sine t, derivative of minus sine t, it is minus sine t, and derivative of 1, it is 0. We simplified, and we get minus sine ti minus sine tj. So this is very easy topic. Just focus on the formula, and if you know the formula, then these questions are very easy. What formula you must know? You must know all the basic formula uh, of different function for derivative, and then you can solve this question very easily. Now we can move to another example. Another example is, for example, if I have this problem, let rt is equal to 2 plus ti plus t square over 2j plus t square root k be the position of particle in space at time t. Now find the velocity, speed, and acceleration of the particle at t is equal to 1. Now, if you look at this example and if you compare with the previous example, in previous example, I did not ask find the velocity, speed, and acceleration at a particular time. Now here I'm asking find the velocity, speed, and acceleration of the particle at t is equal to 1. So here I specified the value of t. So this is the only difference. Otherwise, the question is same. So you will do the same thing. So if you want to find the velocity vector, so what you need first derivative of the position vector. Our position vector is given as rt is equal to this. Now the derivative of 2 is 0. The derivative of t is 1. And then plus, then the derivative of t square is 2t over 2. You write the same thing. Plus derivative of t power half, because you know the value of square root is half, so it will be half t half minus 1. You know the formula for x power n, so that is n x n minus 1. So you use the same formula here. Your n is half and then n minus 1. Now if you simplify this, so this will be 0 plus 1, it will be 1 I plus this 2 will cancel by 2, so this will be tj plus half, and t half minus 1, so this will be minus half. Now if you want to find the value at t is equal to 1, So what you will do, you simply substitute the value of t as 1. So here is no t, here is t, so you put the value 1. Here is t, so you put the value 1. And now you simplify this. So this will be I plus 1 into j, so this will be j. And 1 power minus half, so this will be 1. So it will be only 1 over 2, so 1 over 2k. Now to find the speed, so what you will do, you will take magnitude of the velocity vector. So you already find the velocity vector. There is no need to first find the magnitude of this and then put the value of t as 1. So if you have already find the value velocity vector at t is equal to 1, directly find the magnitude of that. So it means you can find 1 square, then 1 square, and then half square. So you can see here 1 square plus 1 square plus half square and then square root. So this will be our speed. And then you can simplify 1 square is 1, 1 square is 1, 1 over 2 whole square is 1 by 4. And if you simplify this, so this will be 9 by 4 square root. And if you simplify more, this will be 3 by 2. And now to find acceleration. So what you will do to find acceleration, first you find derivative of the velocity vector. So you must find derivative of this velocity vector, not this velocity vector, because this is at t is equal to 1. Now here you can see all this number 1, 1 half. Some student in exam, what they do the mistake, so they find acceleration of this vector, velocity vector, which is wrong because this is at t is equal to 1. So first you have to find acceleration of the velocity vector. So here, so and then later on you will put the value of t. So if you find the acceleration, so that will be first derivative of the velocity. Here is the velocity vector given. Here you can see it is written 1. So the derivative of 1 will be 0. And then here is t, derivative of t is 1. And then here you write half same. And then derivative of t power minus half. So this minus half will come down, and then t raised power minus half minus 1. You already know the formula. Formula of x power n, it is nx n minus 1. So we use the same formula, nx n minus 1. So here your x is just like t. So your acceleration is, if you simplify this, 0 multiply this I, so this will be 0. So no need to write, only we write j. And minus, so 1 by 2 multiply with 1 by 2, minus this, minus into plus, so this will be minus, come outside. So 1 by 2, 1 by 2, so this will be 1 by 4. And t raised power minus 1 by 2 minus 1. If you add this, minus 1 by 2 minus 1, so this will be minus 3 by 2. And now you can put the value of t equal to 1. At t is equal to 1, so what will be acceleration? So what I will do, I will put wherever I will find t. So here is t, so I will put the value of t as 1 here. So 1 power minus 3 by 2. So this will be j minus 1 by 4. 1 power minus 3 by 2, it will be 1. So it will be only j minus 1 by 4k. So this will be the value at t is equal to 1. So this will be your acceleration. So definitely no acceleration. It will not be in terms of t, it will be only a number, because when they put the value of t equal to 1, so here you will not find any t, although I have written here at. So this will be only actually a, not at. So I think the concept is very clear. So what you will do, we can repeat the whole example one more time. So the idea was, same position vector was given, and we have to find the velocity, speed, and acceleration, but at some specific some specific time. So the time t is given as 1. So what we did, we find velocity, which is first derivative of the position vector, and then I put the value of t is equal to 1, and then I find the speed. You know the speed, it is magnitude of the velocity vector. So we find the magnitude of the velocity vector, it means 1 square plus 1 square plus half square and then square root. And then similarly acceleration, we find, first we find derivative of the velocity vector, and then I substitute the value of t as 1. So I hope that will be clear. Now what we can do, I will write here another example, but this example will be your homework. So the example is, it is same idea. Let rt be the position of particle in space at time t. In the following, find the velocity, speed, and acceleration of the particle at the given value of t. Now there are two questions. So first question is rt equal to secant ti plus tangent tj plus 4 over 3 tk. So at t is equal to pi by 6. So you have to find velocity, speed, and acceleration of this position vector. So at t is equal to pi by 6. Similarly, you have to find velocity, acceleration, and speed of this position vector rt, which is equal to e raised power minus ti plus 2 cosine 3tj plus 2 cosine 3tk at t is equal to 0. So it's very simple. Just follow the previous two examples and you can solve. I'm sure you can solve very easily. It's not at all difficult. For you people, I have I have given here. I have given some formulas. So these formulas you must know, and then you can solve this question very easily. For example, we know the derivative of sine is cosine, the derivative of cosine is minus sine, the derivative of tan is secant square, the derivative of secant is secant x tan x, the derivative of e raised power ax is a e raised power ax, and the derivative of x power n, as I explained in the previous example, it is nx n minus 1, and the derivative of cosine ax, because here is, for example, only cosine x. If a is multiplying, just like in this example, you can see cosine 3t. So with 3t, so you will apply, it means this formula number 7, cosine ax. So what we will do, we will write a outside and then minus a sine ax. Similarly, for sine ax, so your formula will be a cosine ax. So you can see here it is sine 3t. So for this, we will use this formula number 8, because here your a is 3. So I think you can easily solve these examples. And still, if you find any problem, any difficulty, you can send me message, or on Moodle we can chat even during our class time. So I hope you people enjoyed this lecture, and this was very easy, very simple. But still, I said in the beginning, as I said in the beginning, this is first time. Definitely, there can be some problem from our side. There can be some problem in understanding from the other side, on from your side. But we should at least try. Maybe first time will fail, maybe second time will succeed, third time will succeed. In the beginning, I said whenever you do something new, so definitely there is some problem. But later on, as time will pass, so things will become more easy. Thank you very much. I hope you enjoyed this lecture, and see you inshallah in next lecture. Assalamu alaikum.